On the last video, I ended with this lottery problem. So before I get into these other practice problems, I want to show you something here. This is actually a game played in Texas called Texas Lotto. And if you'll remember, we found that if you choose 6 numbers from 54 numbers, obviously repetition is not involved, then you can calculate the number of possibilities using 54 choose 6, which turns out to be 25,827,165. What I thought you might find interesting is if you go to the Texas Lotto website and go to the Texas Lotto, how to play Lotto Texas, and you go down and look at, they actually give you the odds of winning the jackpot here. And notice the odds of you matching all 6 out of 6. Notice it's 1 out of, and what's that number? Exactly the number that we got using combinations, 25,827,165. So you can see that it's very important in gaming to be able to calculate these values for these counting techniques. Now these are just some practice problems that I threw together, and so this one is sort of the way I solved this one is I didn't really use any of the techniques that we talked about, but you can solve it. Notice you have a total of 37,451 PhDs earned in 1991. There were 1,164 PhDs in business, and 292 of those were women. And then we know women, we're given that women earn 13,782 PhDs. The question is, how many men earn PhDs in something other than business? Well, the way I did this was I said, well, we know that 13,782 of the PhDs earned were women, so subtract that from the 37,451, and you get that there was 23,669 men that earned PhDs. But we don't want just men that earn PhDs. We want men that earn PhDs in something other than business. So let me see if I can figure out how many of those men earned PhDs in something other than business. So let's talk about the men. How many of the men earned business PhDs? Well, we know that there were 1,164 PhDs in business, and 292 of those were women. So if we subtract 292 from 1164, we get 872. So there were 872 men business PhDs. So now if we subtract the 872 from the total men PhDs, we'll get 23,669 minus 872, which gives us a total of 22,797 men that earn PhDs other than business. Now on this one, it says out of 30 applicants, 11 are female, 17 are college graduates, 7 are bilingual, 3 are female graduates, 2 are bilingual women, 6 are bilingual graduates, and 2 are bilingual female graduates. Now find the number of female graduates that are not bilingual. Okay, so this one's a little tricky. This is a 3-set diagram. So I've drawn 3 circles here. This circle on the left represents all your females. And remember, it says we have 11 female. This circle on the right represents graduates, and it says 17 graduates. And this circle at the bottom is the 7 bilingual. Now, the key was right here where it said 2 are bilingual female graduates. So that's in the intersection of all 3. So I put 2 right there. And then once I got that 2, then I could actually put in, figure out these other little triangular regions on the outside here. And let me show you how I did that. Here it says 3 are female graduates. So that means where the female and the graduates intersect, which would be this little, I'll call that an I right there. This little I right there has to total to 3 because that's where female and graduates intersect. Well, we've already got 2 accounted for here, so that means we got to have 1 here. The next one says we have 2 bilingual women. Well, bilingual women would be in this I right here. So right here. But we've already got 2 accounted for, so that means that we would have 0 here. And then the next one says 6 are bilingual graduates. So the bilingual graduates would be in this I right here. And since we've already got 2 accounted for here, then we would have 4 out here to make it equal 6. Now, all I have to do now, I can fill out these outermost regions by just noting that this circle has to have a total of 11, and I've got 3 accounted for here, so that means I need 8 out here. This circle has to add up to 17, and I've got 7 accounted for here, so 10 would be out here. And then this circle has to add up to 7, and I've got 6 accounted for here, so I've got 1 out here. Now, the final question says, find the number of female graduates that are not bilingual. Now, female graduates, remember, would be in this circle right here, or this I right here. This is female graduates, so pay attention to what I'm circling. This is the intersection of female and graduates, so that's female graduates. But we want to know how many of those are not bilingual. Well, you can see that these 2 are bilingual, and we have 1 that is not bilingual. So your final answer would be 1. 30 members of a club on campus. How many ways can a president, vice president, secretary be elected? Well, since repetition is not allowed and the order would matter here, since we're making assignments, we're assigning in positions, this would be a permutation. So it would just be 30p3. I didn't make the numbers small like I'm supposed to just because I got lazy, but that's 30p3, and that came out to 24,360. Next one, how many 3-letter code words can be selected if there's no restrictions? Now this is out of all 26 letters of the alphabet. If there's no restrictions, then you can say there's 26 ways to fill each spot. So 26 times 26 times 26 is 17,576. Now, if repetition is not allowed, the second question, then you would have 26 times 25 times 24, which is 15,600. A shirt company has 4 designs, 5 patterns, 6 colors, and 3 styles. How many different shirts can be created? Well, this is just the straight multiplication principle. Just multiply 4 times 5 times 6 times 3 and get 360. Number 6 says, how many 5-card hands can be dealt from a standard 52-card deck? So on that one we would have 52 choose 5 or 52C5 because the order is not relevant, and that would give me 2,598,960. The second question says, how many of these hands contain 2 hearts and 3 clubs? Well, you would have to multiply the number of ways to get 2 hearts out of 13 hearts times the number of ways to get 3 clubs out of 13 clubs. So if you take 13 choose 2 times 13 choose 3, and then that's 22,308. Number 10 says 10 horses are entered in a race. How many ways can the horses cross the finish line? Well, this is wanting to know how many ways we can arrange all 10 horses out of 10. So that would just be 10p10 or 10 factorial, and that's 3,628,800. 7 coins are tossed. How many ways can they land? Well, I think you've seen enough of that in the earlier examples, but that would just be 2 times 2 times 2 times 2 times 2 times 2 times 2, or 2 to the 7th, which is 128. A test has 3 true-false questions and 7 multiple-choice questions that have 4 choices each. How many different answer sheets can be submitted? Well, for the 3 true-false questions, you would have 2 times 2 times 2 ways you could answer those. And for the 7 multiple-choice questions, you'd have 4 times 4 times 4 times 4 times 4 times 4 times 4, or 4 to the 7th. So the total number of answer sheets would be 2 to the 3rd times 4 to the 7th, or 131,072. And then the last one here says there are 7 women and 5 men in a class. Instructor must select 5 to be on a committee. How many ways can the instructor select a group that has 3 women and 2 men? Well, to get 3 women and 2 men, you would, out of the 7 women, you would choose 3, and out of the 5 men, you would choose 2, and then you multiply these two together, and you should get 350. What about a group of 2 women and 3 men? Well, out of 7 women, choose 2, and out of the 5 men, choose 3, and multiply those together, you get 210. And a group of all women. Well, that would mean out of the 7 women, you're going to choose all 5 from the 7 women. So 7 choose 5 is 21. And then finally, a group of all men. That would mean out of the 5 men, you choose 5. So 5 choose 5 is simply 1. And so that should give you plenty of practice on these counting procedures. And next, we'll finally get into probability.